Welcome to our webinar today on detecting and investigating cloud crypto mining. We're going to go into how to do that threat hunting in Panther and some of the new search functionality that we've launched to help you do that. So you're going to hear from Casey Hill, as Senior Product Manager here at Panther, as well as Ariel Ropak, our Principal Threat Researcher, on how you can do that today. All right, to get started, we're going to kick off with a quick poll. So let me pop that up for you and you'll be able to vote. All right, so everybody should be able to see that poll. What tools are you currently using to detect, monitor, and investigate threats? If you got a combo of these tools that you're using, we'd love to hear about it in the chat, or you can choose the other. We'll give folks a minute to answer that, and then we'll go ahead and share those results with everybody. All right, if you haven't voted yet, get those votes in. 10 more seconds. Like I said, if you want to share a little bit more about the combo of tools, if you're using a combo or a different tool here, you can always share that in the chat. All right, I'm going to go ahead and share those results. Looks like we've got an interesting mix of folks. Some people are using a SIM, and we let you choose multiple. So if you are using multiple, I guess we covered that in the results. So you can see that there's a solid mix of folks using all these tools to detect and monitor threats. All right. So let me hand things off to Casey, who's going to chat through Panther's search functionality.
Thanks, Katie. And I think you'll need to give me permission to share video.
Oh yeah, let me do that. Sorry, everybody. All right, you should be able to now.
Perfect. Thanks,
There we
Katie. So one of the things that we're gonna walk through today as we're looking at crypto mining is how Panther makes search easy. And we're gonna highlight a couple different recently developed features that support search within Panther. These focus heavily on not needing to leverage SQL to be able to quickly search across logs. This is really helpful when we think about how do we have interactions with security analysts and security engineers and not having one be a dependency on the other, as well as how do we just quickly hone searches without needing to necessarily match up data. And I'll talk about specifically some of that here. So Kate, if you go to the next slide, what we've done is we've kind of taken, perfect. We've taken our existing search and really revamped it from the ground up. So instead of having like a very kind of kludgy experience on top of SQL, we've made it much more kind of approachable is generally how I think about it. So now you can come into the search experience, you can quickly search across using anything from a key value pair to a regular expression to a free text search. And that's going to go ahead and just automatically under the hood generate the SQL for you, search across a single log, or it could search across any of the logs that you've selected. So that cross-log search capability is really powerful when you think about combining data from multiple different data sources. And as we get into both the crypto mining example as some of the stuff to come, we'll talk about how being able to leverage and quickly go across different log types can be a really powerful investigation tool as well as a threat hunting tool. Now, in addition to this, we've started to enhance how we actually normalize the data so that we're not just solely parsing it and normalizing it, but we're also actually performing some sort of structuring. So we're unifying the data model around users and machines so that then you can consistently and reliably look at particular user or machine attributes across different types of logs without necessarily needing to know where those might be located, as those are happening actually on the ingest side in Panther. Now, if we go to the next slide, this is also enriched, which is a really powerful feature. So if we think about, okay, we've now ingested the data, we've normalized it into a specific shape, and then we actually want to now glean additional information. We do this using a number of different enrichment providers, but a couple of the more recently introduced ones were around profile pullers. So here we're pulling in both Okta information as well as Google Workspace information if you have it set up to do so. And that automatically pulls in that enrichment data so that you have a much richer data set so that you can understand things like departments, roles, locations of users. And that way you can really combine this in information together as you're going through and conducting an investigation. And then finally, if we go to the next slide, we're helping to just really make that decision-making process a lot easier as we're displaying the distributions and allowing the ability to quickly get in, hone your searches by clicking to add exclusionary or inclusionary filters and making it just a lot easier for humans to quickly make decisions in these kind of critical points. And from there, let's get into a little bit more specifically both some of the things coming up next, and then we'll get into some of the crypto mining activity and how we handle that within the platform itself. So the final feature that this is a soon currently in development feature is being able to conduct ORs as well as do IOC recognition. So one of the things that we do want to continue to improve upon our search experience is make sure that, as for example, you might get a list of heterogeneous indicators of compromise, and you want to be able to quickly copy and paste those into the search bar, and you want to automatically be able to search across any of your log types to see if those are present in any of your logs. And so that's one of the functionalities within Panther that you'll see coming out here in the next roughly month or so. And with that, let me go ahead and pitch it over to Ariel to talk through kind of the overall crypto mining threats, and we'll demonstrate from there.
Great, thanks, Casey. Let me see if I can turn on my camera here. There we go. All right, hey everybody. Excited to be with you today to talk a little bit about cloud crypto mining and the threats associated with those, kind of what we're seeing out in the wild today, and how Panther can help detect those threats and also help investigate those incidents as they may occur within your environment. So happy to be here and help highlight some of the search features that Casey just mentioned. And actually, if you wouldn't mind just staying on the previous slide for one moment here, give a quick overview of what we're talking about in terms of crypto mining threats. So crypto mining is the act of using your own computer resources to mine cryptocurrency. So the profitability of that exercise is really it depends on the price of the crypto coins being mined. The price obviously fluctuates a lot, but then you're also, cutting into your profit margins is the cost of actually running those compute resources. And the act of mining is very compute intensive. So, I've had a little bit of experience in the past mining some cryptocurrencies. And at the time, this computer I had running in my basement was eating up a lot of electricity, very expensive to actually run. So you're always doing the calculations of, how much crypto am I mining versus how much is my electricity bill. And so there's really a cost benefit analysis to be had there. And so what we're seeing in the threat landscape now is attackers gaining control of other people's compute resources to mine cryptocurrency for themselves. And that's generally referred to as cryptojacking. So hijacking other people's compute resources. So the attackers gain the cryptocurrency that's mined, and they don't have to pay for the electricity or the underlying cloud compute resources that are being used to generate that cryptocurrency. So it's a very attractive proposition to attackers. Generally, much more cost effective, much higher profit upsides because you're not having to pay for those resources yourself. So with that, let's jump to the next slide and talk about, why this is important. This is definitely something that's been in the news quite a bit recently. There's been some really great analysis by some threat intelligence departments out there. So one of the really great ones is a analysis by Palo Alto's Unit 42, where they do a deep dive into a very kind of automated attack sequence where attackers are scanning GitHub for exposed AWS secrets. Then they're using those AWS secrets to gain access to the victim's AWS environment, where they then spin up large numbers of very high compute intensive EC2 resources, where they then install crypto miners and start running those crypto miners. So that's one of the scenarios we'll really delve into today. There's another great analysis by Microsoft's threat intelligence team around the Storm 1283 crypto mining. And again, this is a very similar scenario, just targeting Azure environments versus AWS. So spinning up new Azure VMs, installing crypto miners and mining cryptocurrency that way. We also see recent attacks against web servers, exploiting vulnerabilities in Apache and other web service frameworks. Generally, these are going to be a little bit less profitable for the attackers because the web servers themselves are usually not as, well resourced as other cloud resources. And by gaining access to the underlying cloud administration platform, attackers have the ability to create and spin up more resources than a typical web server would usually have. Still, it's a very widely exploited attack vector, looking for these vulnerable web servers. Obviously, a web server is going to be exposed to the internet, so there's a big attack surface there for attackers to exploit. This has been such a big issue recently that Google Cloud recently last year launched a program that's essentially an insurance policy for crypto mining within GCP environments. I believe it's a $1 million kind of blanket insurance policy that's included with one of their other kind of services. So Google definitely acknowledges that this is a problem, and it's interesting that, rather than focusing on detecting and preventing that type of attack, they're just providing sort of an insurance policy to pay you back if something like this should occur while you're using Google's cloud resources. And then actually just last weekend, there was a news article about some hackers in Ukraine who were arrested by Ukrainian authorities. Allegedly, they had stolen or mined close to $2 million worth of cryptocurrency across all their victims. Now, the impact to the victims isn't necessarily $2 million. It could be more, potentially depending on the cost of the compute resources being used. So that's something to keep in mind. The value of the cryptocurrency being mined isn't necessarily the impact to the victims. And that's something we'll talk about a little bit more in the next slide. So really, these cloud crypto mining attacks are the intersection of, what it looks like to crypto mine and what it looks like to attack cloud environments. So there's several different opportunities for detection for each of these categories. So with crypto mining, obviously we're starting with a piece of software that's designed to mine that cryptocurrency. So usually there's a file hash associated with most of these. These are pretty well-known pieces of software at this point. Of course, it's fairly easy to modify the file hashes of executables. So that's a tactic attackers may use to mask the software that they're using. And again, if attackers are spinning up brand new cloud resources to run these pieces of software, you may not have the EDR software installed because it's a brand new system. But for those web servers, there may be antivirus or EDR software installed to catch the actual executables being dropped on those systems. The other telltale sign is very, very high compute utilization. So most cryptocurrencies use GPUs to perform the computations. There are certain cryptocurrencies out there that have been optimized to be mined on CPU resources, one of them being Monero, which coincidentally is widely used in underground criminal circles because of its difficulty in being traced, the transactions. So in a lot of these attacks, we see Monero being the coin of choice to mine, both because these cloud resources generally have more CPU resources than GPU resources, and Monero is nice for attackers to be able to transfer and not be traced easily. Although with the sort of advent and buildup of LLMs and other types of AI compute resources, there are a lot of cloud environments out there that do offer GPU compute as well. So that's something to keep in mind. On these computers, you'll see a huge spike in resource utilization. These mining softwares generally try to use as much of the available compute resources as possible to really maximize the profitability of that activity. And especially in an attack scenario where the attacker doesn't really care about the longevity or the cost of running at such high resource utilization, they're going to be maxing out the CPUs and GPUs on the systems that they have access to. So, there's definitely the potential to detect these types of attacks in a type of observability software looking for large spikes in resource utilization. There's also a ton of data transfer that happens with crypto mining. The miners are not only sending blocks back and forth between the mining pools, essentially retrieving a block to solve, and then once they've solved it, returning the solved cryptographic block to the mining pool to receive their reward. But they're also exchanging pieces of the blockchain in the peer-to-peer network with other miners. So very high frequency connections to other systems, as well as large amounts of data transferred both in and out. And along the same lines, there's network communications to crypto mining pool domains. So these are community pools of miners who come together to kind of make it more efficient for them to mine, and it kind of levels out the payouts for successfully solving those blocks. And then those mining pools, depending on the protocol or the coin that's being mined, may use certain ports. But using ports for detection can be quite noisy. You get a lot of false positives because you're not guaranteed that a port is only being used for crypto mining, for example. So it's generally more effective, in my experience, to use the DNS requests looking for specific domains. That's much harder to change. And we'll go through, various methods of detecting all of these. So how does this intersect with what we see within cloud attacks? Actually, if you could stay on this slide for one more minute here. So yeah, in cloud attacks, we see generally a exposed API key somewhere, whether that's in GitHub or another type of repository. Attackers gaining access to a cloud account. Usually what they'll do first is enumerate what privileges this account that they've gained access to has. So you may see a lot of, who am I type requests in the cloud environment, trying to figure out if they have the privileges necessary to move on to the next stage of their attack. And then for crypto mining attacks specifically, attackers have been seen creating large numbers of very highly resourced EC2 instances or Azure VMs so that they can really maximize their profits as quickly as possible, because they understand that they're going to be caught sooner or later. So they really try to make as much money as they can while they can. And then one of the commonalities between crypto mining attacks in the cloud and other types of attacks are the modification of startup scripts. So most of the time, when these new cloud resources are created, the attacker will modify the startup script for that resource and then reboot it. And so every time that EC2 instance starts up, it will execute certain software. In this case, that's going to be the the crypto mining software, but it could also be things like encryption software to perform some type of ransomware. This is a big commonality between a lot of different types of cloud attacks. And also data egress is another commonality, whether it's communicating with the mining pool or exfiltrating sensitive data for some type of extortion. We see that a lot as well. Next slide, please. So yeah, if we really dig into the threat scenario that was analyzed by Palo Alto's Unit 42, we can break it down into these different stages, and there are detection opportunities at each of them. And we've got some out-of-the-box detections within Panther for all of these. And what I always like to think about is defense in depth. So we'd like to be able to catch this type of activity as early as possible, but for any number of reasons, a detection might miss certain activities. So you want to have detections at every step of the chain so that you're sufficiently covered. So like we mentioned earlier, this starts out with a very automated process of scanning GitHub repos for exposed secrets. This is something that's a little bit difficult to detect on because you're really just looking for, GitHub repositories being cloned. So that by itself is not really malicious. It's the follow-on activity that is. So being able to chain these events together, being able to detect, chain of events in short periods of time is very powerful. Once those credentials are found, this automated process logs into the AWS instance. There is a GitHub security policy that will automatically quarantine these types of keys, and that activity can be detected. So you're being alerted when built-in security policies within GitHub and AWS are being triggered. From there, assuming that an attacker is able to gain access to an AWS account, they'll usually perform a large number of describe type activities, whether they're describing the AWS account itself, describing what instances may already exist, describing what permissions the user that they're logged in as has, just making sure that they have the permissions necessary to move to the next stage. So looking for a large number of that type of describe event in a short period of time can be effective. It is, there is potential for some false positives there where it could be, legitimate administrator activity, kind of getting an asset inventory or something like that. And then in this case, the next phase would be creating a large number of EC2 instances. So this is something that's definitely good to detect on, looking for a number of EC2 instances created in a short period of time that exceeds the normal threshold for your environment, as well as looking at the type and size of those EC2 instances. So if you are in an environment where you never use anything higher than a medium EC2 instance, and now you're seeing like 12 extra large CPU focused instances created in a short period of time, that's a big red flag. And then, like we mentioned earlier, once those instances are created, the next step will be to modify the user data script so that every time those resources reboot, they'll execute the miner. So this is both a execution technique as well as a persistence technique. Should you reboot those computers, the mining software will continue to run after reboot. And then once the mining software is running, it's obviously going to be communicating out to the crypto mining domains, and that's a great detection opportunity as well. So I think we're going to hop into the demo here at this point. We're going to be focusing on detections for that later stage of the chain. So looking at user data scripts being modified and crypto mining domains being resolved over DNS. Again, it's best to try to detect these early on, but in order to highlight some of the search features and the threat hunting capabilities that Casey mentioned earlier, we're going to sort of start at the end of the chain and work our way backwards to see what that looks like. So let me see if I can share my screen here. Okay. Can you see my screen?
Yep.
Okay, great. All right, so this is an example of one of the alerts being generated in Panther. So we're seeing a IP address making a DNS query to a known crypto mining domain. This is a Monero mining pool called Nanopool. We can see that this is being triggered out of our AWS VPC DNS logs. So there's other types of DNS logs out there, but in this specific instance, we're focused on AWS. So this is kind of what we expect to see from the attack details. You know, this is the log message of the DNS request. These are the IP addresses that were returned, you know, resolving that domain name. The IP addresses could change pretty frequently, so it's much more effective to you know, trigger off of the domain name rather than the IP address. And like Casey was mentioning, Panther is extracting out a lot of these, you know, enriched fields. So identifying things that are domains and IP addresses and grouping those together for easy searching. We're also enriching these logs with things like gray noise and IP info to you know, get some more enriched data around what these IP addresses belong to, who owns them, and other types of information there. Yep, we can see various location data for those IPs, and so as part of this, you know, the next step for a security analyst would maybe be to look at the source IP and say, you know, what system does this IP belong to? What other types of activity is this IP address performing? And at the end of the day, who was responsible for creating this resource and why is it connecting to this crypto domain? So for that, I'm going to hand it back over to Casey, who's going to walk through some of the search capabilities for how you'd kind of work through this alert and work your way backwards through that scenario.
Thanks, Ariel. All right, hopefully my screen's coming through okay. So as Ariel mentioned, we could pivot on the normalized source IP. Another thing we could do is pivot specifically on that kind of known domain that's associated with crypto mining activity. So clicking the little search icon, that's going to pivot us into a search based on that particular attribute. So you'll see it highlights the field and then searches for anywhere that contains that particular value. Now, as I'm looking through this data, I might want to expand the kind of window that I have selected here. So by default, we'll go ahead and look at roughly around the time of the alert for any other activity. So anything across any of the event logs. But given what Ariel was explaining in terms of wanting to understand some of the activity that might happen in advance and who might have spun up some of these instances, I'm going to go ahead and increase the window of time that we're looking at. Now, as I increase the window of time, there's a couple things I want to look out for in my data here, and I want to be able to kind of line some of it up so that I can kind of easily go through it. So to start, I'm going to pull out a couple different fields. I might look at maybe source IPs one. Another field that I might want to highlight in here could be AWS instance IDs could be an interesting one for me. Again, this is automatically extracted within a PNE field. And then I might even want to go in and I can look more specifically in any of these fields. Looking at some of the enrichment data that Ariel pointed out, I could also pull some of this out. So a good example here might be I want to pull out, say, IP info so that I can quickly understand, you know, what locations is this particular, are these events coming from. So here I can quickly kind of just get a grasp of, okay, where are these events coming from? Now, if I look in my data, you're going to notice because I'm searching based solely on that domain, I'm only looking at VPC logs. And so I want to actually expand out so that I can also understand that for these AWS instances, I want to maybe look and make sure I am able to include things like CloudTrail data so I can understand the activity that's actually being generated here. So here I can quickly just click here. What this is going to do is it's going to add a new filter criteria up here. I can do inclusion or exclusion, but for the use case today, we're going to be looking specifically at inclusion. So let's pull out just a couple of those different instance IDs and we can get a better look at what's happening here. So again, searching across all of this data, you're going to notice it expands out a little bit so that now I can see CloudTrail data within here as well. Again, I can quickly kind of see the different locations of users, but really what I want to get to here is I want to look at the events so that I can see what type of activity was being generated within these different instances. So as kind of expected and Ariel alluded to earlier, I get a lot of describes. And so that's partially going to indicate, and then I'm also going to see a lot of start instances. So probably related to starting those EC2 instances. So here I might actually want to look specifically just at these instances so that I can get an understanding of which users or user actually generated that activity. And so I can, again, just quickly kind of hone in. And now I'm going to go ahead and specifically pull out those users. So if I pull out, say, the username here, then I can get an idea and I can actually hone in on the particular user that actually performed that activity, as well as you can see which role they assumed within AWS. So this is really how you can kind of, backtrack or investigate what might have happened here. This is really useful both in investigating, but also if you're doing more kind of threat hunting and you're continuously wanting to kind of follow a trail and see what happened. This is particular to how you might go about that from a investigating cryptocurrency mining using your resources. But there's a couple other use cases that we see customers commonly going to as well within Panther, as well as just in the security space in general. Now, a lot of these use cases, we're focused on how can I do high scale log data and how can I look across multiple different event types? So one of the things that you'll see that's extremely common is cross-tenant impersonation. This can look like essentially it starts with oftentimes anomalous activity. So here you might say, look at your Okta login activity, try to determine if someone's using like a VPN anonymizer, and then you want to look at to see if they've done things like been able to compromise an account. Maybe they've up-leveled permissions or they've created an additional account and then are able to sign in using that newly created account. And so that's one of those where you're going to be looking at maybe the same ultimate vendor, your IDP, but you might be looking across multiple different log types, and you want to be able to kind of quickly do that and pivot across that to understand what that activity looks like. Now, another common scenario that we see customers wanting to be able to both use detection as code for, as well as investigate across multiple different log types, is insider threat and data exfiltrations. Here, a common thing to look at is a large outbound data transfers. So that's one of the things that we've prioritized within our normalized data so that you can hone in on the transferred bytes and you can look particularly at when someone's exfiltrating data. You can also quickly look and identify if things are happening like exposing different buckets of data or S3 buckets to publicly. That's another kind of indication that you might want to look at this. And then also within there, you might want to identify if there's any sort of like large number of access denied or login failures, as those might be indicators of people trying to exfiltrate data or an insider threat potentially. And oftentimes you're looking at VPC flow logs, you might be looking at CloudTrail data. Sometimes you're even incorporating CrowdStrike or GitHub data in terms of being able to identify these types of threats and then wanting to either hunt across those log types or even just conduct an investigation following an alert. And then finally, another scenario that comes up or use case is AWS S3 ransomware. This one's a little bit trickier, but you'd be looking at, again, kind of anomalous account activity. You'd be looking at things like data discovery, data destruction. You'd be looking at whether attackers checking for whether there's object versioning and MFA delete settings on particular resources, as that's ultimately a requirement for being able to encrypt that data and ultimately hold it as a ransom. So those are a few of the various kind of buckets that we see in addition to cryptocurrency mining. And so both detection as code as well as easily being able to search across multiple different log types are really critical in just being able to make sure that you're staying on top of identifying when those are occurring, but also being able to quickly understand what happened as you're going about investigating those types of activities. Now, from there, we wanted to open things up to see if anyone on the call today had any questions for us.